So our speaker this night is Akira Brand, and their presentation is the Developer's Guide to Cybersecurity. Akira is a software developer and educator. Their roles have included employee, contractor, hackathon organizer, and nonprofit leader. They currently work in a developer advocacy at FusionAuth, a Denver company building software to handle authentication, authorization, and user management for any front end for any app. As a recent passion project, Akira and some peers created a weekly hackathon exclusively focused on helping new developers learn the basics of front-end web development called Learn a Bit. You can find them at akirabrand.com. And Akira, whenever you're ready, you can go ahead and screen share and get started.
Awesome, thank you. That's a really good intro. I forgot how cool my my bio is. All right, I'm gonna go ahead and screen share here. Let's do the presenter view. Let's see here. Gonna do a little dance. Share little screens. Okay, can you see a really big thing that says "Learn enough cybersecurity to be dangerous"?
Looks good to me.
Cool. All right. Whoop, lost my. Yeah, 1 second. Sorry. Sometimes presenter view is a little confusing. Okay, here we go. Yeah, so welcome. Thanks everyone for coming tonight. This is my first time attending a Women Who Code meetup. For what it's worth, I volunteered for quite a long time as the adult programs lead with a kind of similar organization called Chick Tech. You all might have heard of them, but I think they're very similar to Women Who Code. We wanted to do some stuff with Women Who Code when I was out in Oregon. It didn't quite work out yet, but who knows? Maybe something will happen there. We have yet to see. The time is long. Yeah, so let's do a little bit about me. Again, my name is Akira. I work in developer relations at a Denver-based company called FusionAuth. What we do here is we do identity as a service. We also do customer identity and access management. So anything that has to do with login, logout, authentication, authorization, OAuth, all that stuff, that's what we handle. My current mission right now is to educate devs on cybersecurity best practices. Cybersecurity is kind of a scary field. It's very vast. It's very wide. There's a lot going on in it, and there's a lot of acronyms and a lot of confusion and not a lot of answers. So that's kind of my mission, is to kind of, again, educate devs on how to kind of write more secure code. As far as questions go, if you want to ask questions, go ahead and put them in the chat. I will be checking it from time to time so that you can ask questions and get them answered. We'll also have a little bit of time at the end to ask questions. Okay, so first off, we're going to talk about the state of the union, so kind of what is going on with the world of cybersecurity right now. And we're going to talk about some just common weaknesses that are found in all apps, but since this is a little bit more front-end focused, we will talk a little bit more about front-end apps. And then we'll have some time for Q&A. So altogether, this will take about 20 to 30 minutes. One thing I want to mention really quickly, just off the bat though, is that good design and good development inherently will make your apps more secure. And being a good developer is inherently tied to writing secure code. So this is not a niche thing. This is not like, oh, I'm a developer that specializes in cybersecurity, or, oh, I'm a cybersecurity engineer and I can do a little bit of software development. These are just basics, and these basics can go a very, very long way. So first off, let's talk about the state of the union, what is going on in the world of cybersecurity. So this right here is a really beautiful data visualization of the world's biggest data breaches. And what I want to show you here, this is it live. You can find this on informationisbeautiful.net. And this is up to date. It's updated, I guess, October 2021, so it might be maybe a few weeks old. As you can see, Facebook recently had 533 million of its users' data leaked. So what you can do if you go to this website, it's actually really cool. You can click on the bubble and get a article about what happened. You can also just hover over it, and from time to time it'll have some information about what happened, and you don't have to navigate off the page. But these are not small numbers, right? So I'm showing you this because I want to illustrate to you guys, sorry, to you all, that cybersecurity is a big deal. And we don't really think about it very often. Each of these breaches are millions and millions of dollars lost for a company. So security doesn't necessarily make you any money, but if it's done wrong, or if there is issues in your cybersecurity, it will cost you money, and it is a lot of money. For what it's worth too, anything you put online that has an IP address, so for example, Internet of Things. So if you have a smart fridge, or you have a Roomba, or you have an Alexa, those have IP addresses. They can get hacked. And because everything is so connected, your smart fridge can actually be used to do what's called a DDoS attack and like take down governments. So this is a big deal as we're all designing and developing software for these devices, especially if you're a JavaScript dev. Okay, let's go back here to the main slides. All right, so what I want to talk about quickly is like the layers of computing. On the top, we have the application layer. This is kind of where most web developers live. You might live a little bit more in like in between 7 and layer 6. So you might be doing some SSL stuff. You might be doing some SSH things, especially when you're doing things like connecting to GitHub, maybe doing some more server to server connections. And then you have sessions, which is layer 5. Transport, that's when it starts to get really close to the hardware. Network, data link, and physical. So the more you go down here, the more close to the hardware you are. So the actual like copper cabling, coaxial cabling, fiber wire in a data center somewhere. Each of these layers has specific things that you can do to guard against cyber attacks. So for what that's worth, each of these places are also what's called an attack vector, which is essentially points of weakness that can be exploited to have a cyber attack. I want to talk about one of the most famous cyber, I won't call it an attack, I'll call it a bug, because that's what it is. So this is an example of cybersecurity vulnerabilities in just regular everyday code that everyone uses. And this is called the Heartbleed Bug. And they made a whole website about it. They made this it's actually a genuinely beautiful logo. I think it kind of reminds me of the 90s, like my goth days. I would have really enjoyed this. But it's a serious security vulnerability in popular open SSL cryptographic software libraries. So if you know what SSL is, it's just a way for computers, so servers or computers of any type, to establish secure connections from one side to another. Everything uses SSL. Nowadays it's TLS, but it used to be SSL. Everything uses it. And what happened is there was major memory leaks coming off of all of the data that was getting transmitted from one side to another. So you could arbitrarily just read data off of AWS, off of DigitalOcean. And this was a problem that nobody fixed for how long do you guys think? I'm gonna like look in the chat, just like put in the chat, how long do you think that this like huge vulnerability in the SSL library was the thing where you could just read arbitrary data? 10 years, a year, 10 years, 5 years. Okay, you guys are really close. It was a thing for 3 years. It was 3 years a problem. And here's the thing. Was it a design flaw? Was it actually something wrong in the SSL or TLS protocol specification? The answer is no. It was completely an implementation problem. So that also kind of illustrates there's cybersecurity issues because of design, and there's cybersecurity issues by using well-designed tools the incorrect way, and that's what happened here. Programming mistakes in popular open SSL libraries were used over and over and over again, and it just exposed this huge bug. So of course they wrote some things to patch this up, but now every single person who used these SSL libraries that had improper implementation needs to be told and needs to now upgrade their library, or they need to roll over to a new library. So just something to keep in mind. And again, this is not meant to scare you. I think a lot of times people come to cybersecurity talks and they walk out like having an existential crisis because of how bad it can seem. It won't be, once you learn more about it, you can see kind of how to guard against it, but just to let you know, like this is why the whole field exists, because there are lots and lots of problems. Okay, however, there are some things to consider when you yourself are coding and you want to think, okay, I want to build a secure app. First thing, how much security do you need? If you're going to have an app that literally just displays recipes, you don't have any users log in, you don't have a user data store, it doesn't connect to any other APIs, it's just a standalone app that just displays recipes that are already in its own database, you might not need as much security as if you're building some kind of a bank that for some weird reason relies on tons and tons of microservices and payments and who knows, maybe it's a hospital banking app and it ties to HIPAA. I mean, who knows, right? But there's different layers, right? Kind of similar to how there's different layers to security and to how computers work, and each layer has its own considerations. It's the same kind of thing with your app and building it. What are your inputs and your outputs? If your inputs are nothing, right? It's just displaying some information, and your output is just some pictures. Again, you may not need as much information as if you are having an app, people are inputting their credit card number, they're inputting their date of birth, they're inputting their social security numbers, you're gonna need a lot more security. Something else to keep in mind is what frameworks are you using? React is great, Angular is fantastic. Vue I don't know about, I'm not gonna say it's good or bad, I just don't know a lot of Vue, right? So what does your framework have already that you can use? And this is really important, this goes back to the Heartbleed bug. Do you understand your framework well enough to use it correctly? One last thing that I'll mention is look for vulnerabilities early, look for vulnerabilities often. It's easier to just fix them as you go along, as opposed to at the very end having maybe your company pay a penetration tester and they're saying, oh yeah, I can get into your app and 25 attack vectors and they're all on Akira's code, right? So you definitely don't want that. All right, let's talk about input and outputs. Each of these things, each of these inputs into your app are places that can have security vulnerabilities. These are attack vectors. So anywhere that someone can put something into your app, they can put something malicious, and you're going to want to start to guard against those things. Common ways to deal with that is scrubbing your data, making sure that people are only allowed to put in things on like what's called an allow list, and things of this nature. We'll get into that a little bit more here in a minute. Okay, let's talk about some common threats. So that's the state of the union. Now we're going to talk common threats. For example, this is called command injection or SQL injection. What someone will do is they will go to a front end page and through a form field, be able to put in some code that will literally run an SQL query against your database. And then all of a sudden, boom, they're able to change anything in that database based on this SQL query. So say you're writing a native form, right? Just with HTML, CSS, and JavaScript. And you don't sanitize your inputs. You don't put anything that checks the inputs. Okay, is there some kind of select that's been written? And when someone says, you know, what's your email address? And like, you need to make sure that people aren't typing in like select all. You would need to have some kind of code to check for that and say, okay, if the word select exists, don't send this information back to the server. Things like this. You can also do an allow list. Oh, here it is, sorry. Forgot to go to the next slide. You can also do an allow list, like saying only allow things that have an @ symbol in them, for example, because then it's a valid email address. It's not SQL. There is a JavaScript command called eval. I'm not super familiar with it, but I did find this in my research. So this is something to look at if you use eval. Don't do it without validating the user input, because it can actually evaluate whatever's inside of those parentheses, and then you could put, the malicious actor could put in SQL that will be sent to your server and then run on your server and do whatever it's going to do. I like to say, pretend it's the early days of COVID and all your form fields are a restaurant, sanitize everything. Okay, let me go to this chat really quick and see if anyone has any questions. It looks like Okay. What does TLS stand for? That's a really good question. I think it stands for Transport Layer Security, but don't quote me on that. We can look at that a little bit later for sure. Transport Layer Security, yeah, buddy. There you go. Got it right. Okay, cool. All right. Okay, so let's see. Let's talk about cross-site scripting now. So let's see here. How many of you have heard of cross-site scripting? Maybe in the chat, just say me or +1 or okay, yep, you've heard of it. Yep, +1. We got a couple people. Yeah, this is really common, right? So cross-site scripting runs malicious JavaScript code on a victim's browser, and it will inject it into form fields or malicious links. So kind of similar to how SQL injection, someone will put in a form like select all from users where user ID is greater than 1, and then all of a sudden they have a list of all your users, right? Same kind of thing here. They could run JavaScript code to run in a victim's browser, maybe to steal some cookies, to steal session IDs, to steal authentic authorization codes. And then the thing is that if they steal things like cookies and sessions IDs and authorization codes, what those are proof of identity. Those are authorization. I don't want to say tokens because they're not all tokens, but those are essentially authorization. We'll just call them things for now, that prove that you are who you say you are. So with this ID, people can get into anywhere. So if an attacker uses cross-site scripting, runs JavaScript on your browser, and takes your session ID, they can now present that session ID to anywhere on the internet and see who takes it. So if your bank takes a session ID and it doesn't matter who passes it to them, boom, they're in your bank and they can take all your money. So that's scary, right? Well, how do we fix it? Hey, what do you know? Sanitize your user inputs, right? So this is basic stuff. This is not stuff that is highfalutin, hoity-toity coding, right? It's just basic sanitize your user inputs. Leverage your frameworks. React has great, again, React, Angular, bunch of front-end frameworks have really good ways to take care of this. And again, make sure you know what the framework is allowing you to do and use the tool correctly. You can set appropriate headers. You can also leverage the content security policy. So this is an HTTP response header. It allows you to put certain things on an access list, right? So earlier on, we were talking about an allow list. So this is saying, okay, in my HTML, in anything that's going into a form, I'm only going to allow these types of things. So only accept JavaScript files from this server, only accept JavaScript files that are from maybe these 5 servers. Don't let inline CSS run. Don't let different HTML run that isn't already on this page. There's a really good cheat sheet that I will put in the chat right now if anyone feels like perusing that while I'm talking. This is like a whole cheat sheet that OAuth has. I mentioned this earlier in a breakout room. They're a fantastic resource. They treat this any HTML page like a template and with slots, right? And where a developer is allowed to put untrusted data. And then it kind of shows you how to handle that. So really good stuff. Okay. I know we're at 17 minutes, so we're gonna go over CSRF here, and then we'll kind of see how much time we have left. But this is called cross-site request forgery. This is another common threat. It's also not always pronounced as cross-site request forgery. People shorten it to CSRF. So here's the story. Once upon a time, you were checking your email and you were like, whoa, there's like a really intense email. It says this suspicious bank activity. This is nerve-wracking. Okay, I need to open this email. So you open this email as your first mistake. And you see a message that says there's suspicious activity that has been noted on your account. Someone has withdrawn $1,000. Was this you at XYZ shoe store? Signed bankofamerica.com. You think, oh no, that's my bank. Like, who put $1,000 charge for shoes? That certainly wasn't me. No, for real, it wasn't me. What am I gonna do? I need to click the link and re-verify my account and give them my info and make sure I'm all logged in and we're all good. Well, guess what? That was not the Bank of America. That was an attacker sending you a fake email that says Bank of America with 2 R's, but they are counting on your emotional response. to say that, oh no, I really need to figure this out. However, on your browser, you probably have already logged onto your bank at some point. So what's going to happen is that while you're clicking on this link, the attacker is going to redirect that to their malicious server. They're going to steal that cookie or steal that JSON web token or whatever it is, and then they're going to use that cookie to authenticate to a real bank server. There's ways to make your cookies not able to do this. There's ways to sign JSON web tokens when you create them or when you use them from an auth server, so that this can't happen. But still, it's very, very common. I can't remember the number, but I think it was like $4.3 billion are lost annually from attacks like this. So it's a bummer. So there's a couple ways that you can handle this, right? First thing is the same origin policy. So the same origin policy limits how one website or tab can interact with other websites open in the same browser. As a front-end developer, you probably get a lot of CORS errors. This is kind of where a lot of this comes from, right? Oh, sorry, there's a cross-origin request. I can't do it. We need to do the same origin policy. And this is why it helps protect against CSRF. It's a PITA, but it does help protect against some cyber attacks. So this is kind of the main way to protect against it. So again, you can't read from one origin onto another site. For what it's worth, you can also, anytime you're going to use something that's going to be an authorization token, like a JSON web token, always sign it. And we can get into that a little tiny bit later, but if you ever use JSON web tokens to do authentication, make sure they are signed. Okay, so let's look at some examples here. So we have maybe like store.company.com/dir2/other.html. Okay, same origin, whose only the path differs. Same thing as the second one, the same origin, only the path differs. However, this third one would violate that rule because it's actually a different protocol. So you can see these first two, HTTP, and then the third one, HTTPS, different protocol. Sorry, can't help you. And so on and so forth. So this is an example of stop in action. Jen says, and then verify the signature. Absolutely, yes, 100%. Always verify the signature. That's a very important part. Thank you for that. Okay. For what it's worth, this is how you can fix it. Aside from that, see if your framework has a built-in CSRF functionality. Use it correctly. There's quite a lot of stuff going on, like you saw again with Heartbleed and other attacks, where a framework will have a CSRF protection inside of it, and people don't check that they know exactly how to use it, so it gets used incorrectly. People make mistakes. We're all human, and then boom, someone's getting a CSRF request. Sorry, CSRF issues. Okay, let's see here. There's a couple other ways to fix it. For example, including a random token with all your requests without the use of cookies. You can store that in a JOT or a JSON web token. You can also add tokens to any request and mutate the state of your app. Validate those tokens then on the server side. So if you're doing server-side token validation, that is a fantastic way to guard against CSRF and many other cyber attacks. Okay, let's see here. We're at 22 minutes. I'm going to skip the session management and the OAuth flow because that is like a whole talk in and of itself. And I want to get to fixing things in general, right? Number one, regularly update your dependencies. Dependencies can have a lot of depreciations, or I can never remember if it's deprecation or depreciation. I kind of started working in tech when it was all remote work, so I didn't have enough people around to be like, it's deprecation. Regardless, they go down, right? They break all the time. People are constantly fixing them. Update your dependencies quite often. That'll help. Avoid your framework gotchas. There's a couple examples here, and again, I'll post the slides when we're done of some gotchas from React and some gotchas from Vue and whatnot. And yeah, let's see what else we got here. There's some further learning I'm going to put in. Again, I'm kind of speeding through because I want to have some time for questions. And I think as far as that goes, that is that. So yes, I definitely want to open it up for questions. Here's how you can reach me if you want to. You find me on Twitter if I can remember my login. Or you can email me. I'm definitely happy to answer any questions offline. Or if you think of something at 3 in the morning and you're like, gosh, wow, I really wish I remember that thing that Akira said about CSurf. Email me and I'll get back to you when I get back to you. But does anybody have any questions right now? Yeah, go ahead. If you want to type it in the chat, you can. And you can
whatever works. So are you familiar with React and some of the built-in security features? Because I've read a little bit online, but I feel like I'm just too new to really, I want to like delve in and like start building things the right way, the secure way, you know,
Totally.
rather than learning it a year from now. No.
No, that's a really good question. I'm only mildly familiar with React itself, right? But I think the biggest takeaway I would tell you is that, again, good code is secure code. So if you're using like test-driven development, if your code is, if you're like doing code reviews and people are not like, you know, oh, this code kind of smells a little funky and you're fixing that, you know what I mean? Like code smell, you know, that kind of stuff. And then if you are looking at, for example, if you are building a form in React, take a little time to Google like, okay, how to build secure forms in React.
Yeah.
If you are doing post requests to put data onto servers elsewhere, be like how to do secure post requests via React.
Yeah.
And I think you'll get some good insight that way. And I think honestly too, what I would do, especially since you're a new dev and if you're just getting into the field, and I'm not sure if you have your first job yet, but if you want to really set yourself apart, like write a few blog posts about like how you built a secure form, a secure whatever in React, and people are like, oh my god, that's like amazing. So yeah, that can really help.
That's good advice.
Yeah, totally. Okay, let's see. There's a few questions in the chat. Does that answer your question before I move on? Cool. All right.
Yes.
There's a few questions in the chat. Let me like answer a couple in the chat, and then if someone else wants to chime in, and then I can go back to the chat. Abril, I think I'm saying your name right. Abril. Please correct me if I'm wrong. You're like, no, that is incorrect. Yes, there are definitely good learning materials. What I'm gonna do, I will post these slides, and these are 4 fantastic materials, which is so funny that they just kind of linked, they just became hyperlinks, and I was like, oh, they're just clearly gonna know the hyperlink from the title. But yeah, these are great learning materials. Like I said at the beginning, OAuth is fantastic. Black Hat is fantastic. We have a book called The Modern Guide to OAuth, and what this is it'll teach you authentication grants, and it'll teach you how to build them and integrate them with your app. They do it with the JavaScript app as like an example, but authentication and authorization is a huge component of cybersecurity, which we didn't really have, ironically, enough time to go over because there just wasn't enough time. But what you can do is you can get this ebook and actually try to build the example of the authentication code grant with JavaScript, and you will learn so much about cybersecurity for sure, especially about like decrypting and private keys, all kinds of good stuff. Ricardo wants to know, what was the name of the hackathon that you host? That's a great question. So I did this a while ago. I don't currently host it anymore. However, it is called Learn a Bit. I'm going to put it in the chat. A friend of mine was the initiator of this. He said, hey, we really need to like help totally new devs like get better at just HTML and CSS. And I said, okay, I want to help you with that. What you can do is you can go to mintbean.io, which is the website of like the kind of umbrella company that hosts all these hackathons, and that's one of the ones they host. So yeah, go there and go learn a bit. Okay, who has questions in voice chat? Does anyone have any more voice questions? I can also just keep going through the regular chat questions. Okay, let's go through a little more of the chat questions. Okay, Sherry. Sherry wants to know, is there a more secure method in JavaScript than set timeout for asynchronicity? That is a good question that I don't know the answer to, but I really want to know the answer to. What I'm gonna do, here's what I like to do when I have questions that I don't know, is I'm gonna take a note of that and I'm gonna Google it and figure it out, and then I'll post it on my Twitter. So check my Twitter later and I will figure that out. I don't know, but I want to know now. Okay, let's see. Jen wants to know, what was the most surprising thing that you learned when getting into your role? The most surprising thing I learned was probably how much cryptography influences everyone's life on a daily basis and we don't know it. Like all this crazy math is constantly in our life, through things like authentication and just encryption and decryption of messages throughout the internet. That was amazing to me. Like it was and I don't mean like, oh wow, that's kind of like okay. It was like genuinely amazing. It's like, wow, the more I learn about tech, the more that blows my mind. Okay, cool. Cass has a burning question regarding pen testing. I will do my
Yes.
best. I don't know a lot about pen testing, but hit me. What you got?
Okay. Well, maybe you know about this, or maybe you know just some people in the community who've done this. But one thing I was thinking of could be like as I build stuff, as I go, like, because sometimes like if you're the one building it, you don't see the vulnerabilities as much as like someone else who's coming in from the outside of your application. Like, do people do like, hey, try to hack my app, please? Like, let's do a trade and then I'll try to hack yours, or like, I don't know.
Yeah, they do. So people will actually hire like professional pen testers.
Yeah.
So those are people that like do penetration testing on a company's app, like for money. Sometimes what also companies will do is called bug bounty, which is when they will pay you to like break their app. They don't like organize it. They're not like, come break my app. It's like, yeah, if you find something that's broken, like open an issue, and if it's legit, then we'll pay you like $50 or whatever it is, right? So that's a good way to do it. As far as like breaking your own app or like breaking into your own app, that's where I would recommend looking at like Black Hat. I'm gonna put that in the chat, like blackhat.com. They do like trainings on busting into people's apps. And then you can just try out those skills on your own app. I would say again though, going back to that basic tenet that good code is inherently more secure. If you're trying to like become a really, really good secure coder, definitely just get your code reviewed by like amazing people. Like find those mentors that can really have a good reputation for writing good, clean, secure code, and have them review your code. And then that can maybe help you a little bit more as a programmer, because then they'll be like, here's exactly where it went wrong in your programming. Whereas a penetration tester will just be like, oh yeah, broke your app, fix it. So kind of
that's really good
direction you
advice
want
for
to go.
me. Yeah, thank
totally.
you. Okay.
Yeah. Or you can try breaking other people's apps, right? Like try it out. Like find somewhere that does a bug bounty and like try to find vulnerabilities. Like some of the best ways to learn about vulnerabilities is to like become a hacker for a night, put your hoodie on and do that. Just kidding, it's way more boring than that. Okay, let's see. We have time probably for like one more question. We're a little bit over time, but let's do one more if anyone has one more. And if not, then I will say thank you and good night for the evening. So let's wait maybe like another 10 seconds.
I can ask another one.
Yeah, go ahead.
So something we struggle with a lot at work is our Dependabots just sort of piling up and no one looks at them. Do you have any advice on like good workplace habits to actually get them addressed?
That's a good question. At our workplace, we just make it a habit to merge them as often and fix them as often as we can. If you have a ton of them, it's just maybe time to allocate a little developer time to that backlog. Yeah, I'm not the Dependabot necessarily, the Dependabot like cheerleader or whatever it's called, but we do have a couple individuals in our company that are like, okay guys, like time to fix your Dependabot warnings. And we just do. So yeah, unfortunately it's just something that you kind of, at least for us, what's worked is just staying on top of it. Or you can just silence it and pretend it didn't exist. That's a good way to handle it. For what it's worth, my own personal side projects are like Dependabot nightmares. So I should probably practice what I preach a little bit on that one.
The annoying thing about Dependabot is like, even if you're not working on the repo anymore, it like keeps sending you emails. And you're like, how do I just stop this? This is done. I'm done
Yeah.
with this.
You gotta like delete the repo, which is like sad.
Yeah.
All right, y'all. Well, thank you so much for having me. I really appreciate the time. If you want, that's a QR code to get the free modern guide to OAuth. It has a bunch of really good resources in there, especially delving really deep into the authorization and authentication side of cybersecurity. There's my email if you have questions, or my Twitter if you want to like tweet at me or go into my Twitter inbox. Don't send me a smoke signal. That is way too much effort, and I won't see it anyway. So thanks again, you guys.